Which element is more electronegative, sulfur, arsenic, or strontium? We answer questions like this on a two-tier method. First is looking for general trends and then looking for exceptions to the trends. So for general trends, we look at the periodic table, sulfur, arsenic, and strontium. Strontium is a metal that is going to be the most electropositive or least electronegative. Arsenic is a metalloid, and then sulfur is a non-metal. Sulfur, being closest toward fluorine, is going to be the more electronegative. We don't have any adjacent elements where we have to look for exceptions in the periodic trend. So sulfur will be our most electronegative element. Lewis structures: CH3, CO2, CH3. Organic compounds love to form chains with carbons, and they can include oxygen and nitrogen in those chains. Now, this little structure will take a little bit of practice to get used to what that is going to be. CH3 is obviously going to be C, carbon, with 3 hydrogens on it. So another carbon comes next. We have to figure out what to do with the 2 oxygens, and then we end up with the CH3. Well, if you play around with the oxygens, there's only one combination, one pairing that will allow a valid Lewis structure, and that will be a oxygen on the side and then another oxygen between the next carbon. And to fill in the electrons, it's going to take a couple pairs on that oxygen, a couple pairs on this one, plus another double bond. If you try to work this out initially by putting the electrons on the oxygen, we'd see we're missing electrons on the carbon. If you put them on the carbon, we'd be missing them on the oxygen. The only pairing that works will be a double bond on the side here. And this is the valid structure for this compound. If we look at formal charges, the hydrogens, formal charge are valence electrons minus assigned electrons. And of course, hydrogen has 1 valence electron. Hydrogen has 1 bond. They get half the bonding electrons. So there's 2 electrons in the bond. That means it has 1 of those electrons. So the formal charge on the hydrogens are all 0. All the hydrogens are the same with 1 bond. If we look at the carbons, just check all the carbons. All the carbons have 4 bonds around them. That's what we expect. We almost never expect to see any lone pairs on carbon. So carbon starts off with 4 valence electrons, and it has 4 bonds. That's 8 electrons. It gets half of those bonding electrons, so it's assigned 4 electrons. So again, its formal charge is 0. For oxygen, it starts off with 6 valence electrons. If we look at these 2 oxygens, they both have 2 bonds and 2 lone pairs. So it's going to get all of the lone pair electrons. That's 4 electrons. It has 2 bonds, 4 electrons total, so it gets half of those. So its assigned electrons are going to be 4 plus 2, or 6 assigned electrons. So its formal charge is also 0. So that shows us that this is a good structure for this compound.